ABS plastic is one of the most common types of plastic. It has stable overall performance and is easy to process, so it's the top choice for product designers in all kinds of fields. Even so, some designers still have a headache about the ABS products they design. The design drawings are perfect, but all kinds of problems come up during production. They're worried that the details will be messed up and the costs will get out of control. Maybe you should take a little time to watch this video. By learning about the knowledge of ABS injection molding, whether you're a product designer or a processing manufacturer, you can handle things easily in your future design and production work. For example, the nice outer shell of the smartphone that you use every day, its smooth feel and strong protection are all because of the accurate ABS injection molding. Then, when it comes to cars that we must have when we go out, many parts inside and outside the car, like the good-looking and comfortable interior panels and the tough and reliable bumpers, are all made by this process. And look at the shells of all kinds of medical equipment in hospitals and the seat accessories in airplanes. The ABS injection molding process is just like a magical craftsman. With its own special advantages, it can perfectly shape the materials into all kinds of products that meet people's different needs. It has spread widely into every part of our life and is always making our life experience better. When product designers are designing products made of ABS materials and taking the subsequent ABS injection molding process into consideration, what aspects should they think about during the design process? Keep it uniform. The minimum wall thickness should not be less than 0.1 millimeters. Adjust it according to the functions to prevent uneven shrinkage and material shortage. Set a draft angle of 0.5 degrees, 3 degrees to avoid undercuts. Use special demolding mechanisms like sliders and lifters when necessary. Hide the gate or place it in a position that won't affect the appearance. Optimize the product shape to reduce weld lines. Reasonably set ribs inside to enhance stability. The thickness of the ribs should be 0.8 times that of the wall thickness. Pay attention to the layout and spacing. Place it in a position where it has little impact on the appearance while also taking into account the product's functions to make sure it doesn't affect assembly, sealing, and so on. Besides these design points, product designers should also understand how excellent injection molding factories implement optimization strategies for ABS injection molding. This will help product designers find a solid and reliable partner. Since the mold cavity temperature and the low melting point of the material play a crucial role in production efficiency and quality when injecting ABS, smart injection molding manufacturers will adopt the following strategies. 1. Use dynamic temperature control technology. 2. Select modified ABS. 3. Optimize the design of the runner. Next, let's take a look at a case of ABS injection molding from First Mold Injection Molding Company. The production target this time is in battery tray with a size of 800mm x 600mm. It is required to have a smooth and flawless surface, with warpage deformation less than plus 0.5 meters, and at the same time possess high impact resistance. The existing challenges include optimization of processes and parameters. 1. Material selection. Use modified high flowability ABS. In order to enhance dimensional stability, choose glass fiber reinforced ABS. 2. Adjustment of mold cavity temperature control. Filling stage. Set the mold cavity temperature at 85 degrees Celsius to increase the melt fluidity. Cooling stage. Utilize the dynamic temperature control technology to quickly reduce the mold cavity temperature to 40 degrees Celsius and shorten the cooling time. 3. Optimization of injection molding process parameters. Injection pressure. Increase it to 85 MPa to ensure that the melt is completely filled. Injection speed. Use the medium speed mode, 40, 60 mm, to avoid shear-induced temperature drop caused by excessive speed. Holding pressure stage. Adjust it to 6 seconds to evenly distribute the melt density and reduce internal stress. Back pressure setting. Set it at 10 MPa to ensure the uniformity of the melt density. 4. Runner and gate design. Optimize the runner design to a balanced Y-shaped distribution to ensure that the melt reaches each key position simultaneously. Switch to a hot runner system to maintain the consistency of the melt temperature and reduce weld lines. Final results. Through the optimization of the runner and mold cavity temperature control, the weld lines have been significantly reduced by 90%. The warpage is controlled within plus 0.3 meter, reaching the top level in the industry. The surface finish has reached the SPI A2 standard, meeting the requirements of the high-end automotive market. the rejection rate has dropped to 2%, and the production cycle has been reduced from 45 seconds to 38 seconds. ABS injection molding is not only a technology, but also an art of details. How to design a more efficient production process based on material characteristics. How much potential does the dynamic mold temperature control technology have in the future optimization of injection molding? Which processing details are overlooked but can bring significant quality improvements? Let's pay attention to every detail in the mold injection molding industry, as they often determine the success or failure of efficiency and quality.